Okay, I'm going to go through all these, the simple ones, then do this second one and let you finalize it. And then we do this later on, so we can do that on another video. I can record it on another video. Okay, so what I'd like to do first of all, just this simple thing. This we spoke about it yesterday, but let me just formally put it there. So what we'd like to do is, well, I'm saying using also the I changed the lab to add this single linked list as well. So just to use these two, using these two classes, we'd like to change this DLL, this LL stack, using this DLL stack. So basically in the lab, in the files, we had this file over here, which is this LL stack using this linked list, the java.utils linked list. And instead of using that, we don't want to use this one. We'd like to use this from the DLL, double linked list, the one that we were working on last time on lab 3. So what I'm going to do, first of all, I'm going to copy, because I want to keep that one. Control C, Control V, and then name it DLL stack. Refactor. Okay, just remove this, we don't need it, and then we replace this with DLL. Now many of these, I can also, actually I prefer to have something like this. You put here just the declaration, and then you put the initialization inside the constructor, even though it's the same thing. Anyways, alright, now what we would like to do is to make sure that all the methods are still working. We have some that are working, but this top element is not the get last. This is not okay, because so what we're interested in is not the last one, is actually get first. So probably even in this one, this stack needs to be corrected, because this top and the get last, this is going to also give us the tail. Get last, we just get for the last node, which is not what we'd like to do, unless they add, whenever they add, unless add is going to always add to the to the tail. If it adds to the tail, then if we'd like to get the top element, we're going to look at it that way. And if we look at this add, what does it do? Oh no, in the linked list, if I look at this add, it adds to the last. So actually it makes sense. So this is not a problem. It was working this way because this add adds to the tail. And so if I'd like to get the first one, I'm just removing from the tail. So because my list, every time I add it to the tail. If I need to pop, I need to pop from the tail. So that's okay. But when I'm using my DLL stack, I'm adding. If I'd like to do the same, I should add, keep this to the last, and then if I'd like to do this, so just remove from the head. No, remove from tail, but we don't have this thing. I can delete. We have delete from tail. So this is one way to do that. Or then this is delete from tail when I pop, and if I add to the tail, which means now let me just show this paint. Now if what I'm doing, it's the representation is different, but the idea is the same. Now this is what logically happens. If I add to something to the stack, it just keeps adding to the stack. Let's say, for example, I add 5, then 10, then 2. This is what happens. But if I use it like now in the double linked list, I add 5, then I add to the tail the 10, and I add to the tail the 2. So when I pop, I need to pop from the tail. So that's the idea. Or what I can do, instead of doing it this way, so this is it was like this, and then when I corrected it by using add to tail here, now this is going to work the same way. Yes. You did not get what I just explained? Yeah. Okay. Now this is a stack, right? Yeah, this is the stack. Now if we'd like to represent this with a double linked list, I push 5, so it was empty. This is going to be 5. Right? Okay. Now if I push 10, what is going to happen? Using that implementation, I'm adding to the tail. Well, my tail is the first element. Why? Because when I pop from the tail. So I remove from here. If I remove, I'm going to remove this one, which is the tail. So that's what I was trying to say. Now when we add another one, the 2 is going to add it to the tail again. But when I'm popping, I'm going to pop the one from the tail. Now this is one way to do that. The other way is that instead of doing this, I do it differently, which means I add to the head. Now when I push 5, I can put 5 here. This is my 5. Okay? Then if I push 10, I'm going to add to the head, which means I add it here. But if I add to the head, I need to delete from the head. So now if I push, I pop after this 10, I need to remove from the head. So this is one way. Another way is just make get first, delete from head, and add to the head. So both ways are okay. One of them is that you use your head as the last element that you enter and the last element you're going to, the first element you're going to get out, or use the tail as the last element where you're going to put something or pop something from it.
Every number I will add it will be up.
It depends on, with using this, yes, it will be, well, there's no up, there's right and left here. On the way we represent the linked list, there's no up, right? It's just right and left. Now my right and left is going to be either the top or the bottom, depending on my implementation. Now if for example I use now this to the head, that means I put 5, then 2, then 10, then 2, which means I'm adding to the head, which means where's my top? The top is the head. The top of the stack is the head. Now if I do it with the previous version where it was like add to tail, delete from tail, and give me the last one, that's the top element. Now I'm looking at the top element is not going to be this way, but hold on, cancel. So it's going to be, now when I add 5, I add the first one, there's no tail, there's no head, everything is one place. Then when I add, I'm going to add to the tail, which means now my tail is my head. Sorry, my tail is the top. And then I add another one, that's the tail again, but that's the top for me. If I change it to this. Yesterday I said something, well, this is wrong because we were using this to always go from the head. But actually we can go both ways. Is that okay, inshallah? So that's the first part. This is the DLL stack. Now if I'd like to use a single linked list to implement the stack, we had this one, single linked list that we had here, SLL. We could use that, or I'm going to maybe copy and paste. So from that, once I copied it, okay, I could just have made the link, but let me make the link. That will be much more smarter actually. And what I'm going to do, I'm just going to copy this one, Control C, Control V, and then call it SLL stack. Now instead of doing this, I'm going to use single linked list and of course single linked list, and it tells me, well, I don't find single linked list, you want to use it, whatever. Well, no, I'm just going to say you're going to find it, import, and but it's not going to be visible to it. Yeah, anyways, so let me just copy it for faster. I don't want to, let me copy. Yeah, it's just faster. Does not depend on, what did I do? Maybe I did not copy it, I just tried to move it. Copy, Control C, Control V. Okay, now this is not going to be complete anymore, but now I need to fix something else. Now I don't have the clear because the single linked list here do not have any clear. delete. No, I want to delete all of them. But do I have something like delete all? There's no delete all. As you can see here, you see there's delete and there's no delete all. There's print all, but there's no delete all. This from head, this from tail. Okay, the easiest way, what should I do?
Copy it from the DLL.
Yeah, or I can just do this. Isn't this going to do the same thing as clear? Because when we do this, what is going to happen?
Yeah. But no.
That's clear, right? Let's see the clear here. Double linked list, where is it? Here. The clear. That's the same thing. So I could create a new method called clear that is exactly the same thing, or I could just do this, which is just create a new instance of the single linked list. Is going to put the head and tail to be null, and that's clear. Is that okay? Now this get last, there's no get last, so now I need to maybe implement that get last. How can I get last in a single linked list? I mean, which one is the easiest? Now I can also, this single linked list, I can have it to be the head to be the top of the stack, or the tail to be the top of the stack. So what do I have? Do I have something? Let's see, what do I have here in terms of the different things? I have find, I have delete, but I don't want to delete. I just would like to be able to see without deleting. So anyways, I have to now decide what I would like. If I would like to do this get last thing, I need to, or get first, whatever. Just now, if I do get first, that means I'm not deleting from the tail. I need to delete from the head and add to the head. Now get first, I need to implement that. So I need to go here and implement this get first. So how do I get first? It's kind of easier to get the first than to get the last. Or, well, it doesn't matter because we have head and tail. So for us, in terms of the, in terms of the processing and the load that needs to be done, the actions that need to be done, it's basically the same. Because now, if I'd like to have, it's t get first. Now we're doing get first. So get first is going to be return head dot info. If it was get last, return tail dot info. But before doing this, always there's something I need to check.
It's not empty.
Is not null, yes. Because if it's null, this is going to raise an exception. You cannot call the info of something that is null. So I need to, if the head is equal to null, I need to return null. Else I return whatever. Or I can write it in a different way. I don't know if you have seen this. Which is basically, again, that's the same thing. I'm asking a question, is this null? Yes, return null. If it's null, no, return this. And that's get first. If I was to do get last just for fun, get last would be and tail. That's the same thing. So that's the single linked list stack. Same idea, just different ways. All right, so that's the first part. Yes.
I'm going to ask you about what you did second job.
Which one?
For the first.
This one? Yeah.
That's all the work you have.
One thing to return.
Yeah, one thing.
Yes. If you have one thing to return and you don't have a lot of statements inside of the if, yes. And because if you have more things to do, that's not what you would like to use. For example, I'd like to, if it's not null, I would like to return the head and also do some display something before returning, so it doesn't work. This is just some kind of shortcut for this special case when you have just like two things to be the result.
What's the difference of question mark and
It's just an if in a weird in a one line. It's a one line if else. That's all it is. This is exactly the same thing as if you do this if maybe if else. When you have if this head is equal to null, then you return null, else you return head.info. So instead of having these whole thing, you can have them here as a shortcut basically, because this means the same thing. If head is null, then we return null. So this is going to be the result of all this is going to be null. So I'm going to return null. If then this is false, so the result of the whole thing is going to be this. So I'm going to return head.info. So that's what it means. It's a shortcut, a shorter version of if else. All right. I'm just curious. I think always use it with if else, and it works only with if else. There's no like simple if version of that. There's not. It's yeah. Well, I think so. So that's the idea behind that. So this first part of here, and then write a test double based on this test int to use this DLL instead. Well, basically it's just the same thing. It's not something complicated, honestly. Just a copy and paste. So you just do this, Control C, Control V, and then name it test double stack. And then we just change everything. Instead of first of all this DLL stack, we use DLL, and then we just yeah, instead of integer top double, and that's very simple. I mean, okay, it's complain about the push thing. It's about the it's the int here, the problem. So we need to make it double. But then we still have a problem. The method push double cannot find simple push. So this stack here, which has DLL, does it have a push? So I need to put the push. So when I say push, then what should happen? So I need to create public void push. So where do you want to push? At the head or to the tail? Tail? It's up to you now. We have a double linked list, right? Now which one is going to be the head? You decide. Is this sorry, when I say the head, I mean what I mean is which one is going to be the top of the stack. So this is my stack. If I do this, do 5 and 10, that means the head is now which one? It depends, because you can do the same thing by having the top to be the head. So if the top is the head, which means every time I add, I'm going to add 2, then I add to the head 5, and then I add to the head 10, and then my top is the head. Or I can now make my tail to be, I mean, my tail is the top. So the top is the tail, or tail is the top. Let's keep the same format. Top is the tail. Now if the top is the tail, if I'm adding the 2, well, I'm adding the 2, and then if I add the 5, I push the 5, it's going to be go to the tail, go to the tail. So now my question is, which one of these two versions you would like to have? I mean, is it we add to the head or we add to the tail? So we add to the head. You had a question, Qasim?
because you confuse us when you say 205. You can't take something down. You should start from 10.
No, you can put something. Oh, okay. No, I'm saying to have this stack, I should have pushed 2 first, then pushed 5, then pushed 10.
So 10, 5, 2, that means add to the tail.
10, 5, 2, that means add to the head.
Because we
Because
put
we,
10 first,
no,
then we add.
no, we don't put 10 first. Now to have this as a stack, we don't put 10 first. Because the first element that was pushed in the stack, which one is it? 2, so we put 2. Okay, then I put if I push 5, now according to this 5 is
The new head. The new tail.
well, if you say the new tail, I'm going to put it here. If you say the new head, I'm going to put it here.
New head.
So if I'm using this, this is the new head, so I'm adding to the head. Now if I push 10 again, add it to the head. It's just a way of representing it.
When we pop, we use the same way, the same axis.
Exactly, you should be consistent. If you push to the head, because if you when you push, you add to the head. When you pop, you should remove from the head. Now, if you push to the head and remove from the tail, well, that's another thing. You know, that's not a stack. And basically, that's what we're going to be doing next week. That's a queue. But we're not there yet. That's not what we want. We want, when we push from a place, the last one that was added is the first one to get out. So
So it doesn't matter.
we just need to decide, pick a decision, decide something. Am I going to add to the head or to the tail, and then stick to it? If I add to the head, I remove from the head. If I add to the tail, I remove from the tail. But I'm not going to do both. So now if I do something like this and I want to add to the head, I'm going to, when I push an element like this, I'd like to add to head, and I'm not going to do anything else, which means now my list is going to also, if I pop, the pop should delete from the head. It's just delete from head. I basically need to return something. So now when I push to the head is empty, there's nothing. When I push again, I push the head. When I push, I add to the head. When I pop, I delete from the head. So when I pop, this is the first one to be removed, and that's the stack. That's how stack behaves. Yes.
Why is it dramatic
Which one?
as it is? Like delete
Because I wanted here, as you can see, this code here is using the pop and push, and there's no method pop and push in the DLL, so I had to add them.
you can use
Or you can use this to be add to head, add to tail, yes. But we would like to use the terminology of a stack to push pop, which makes it more convenient. So we just make it easy for someone who wants to use this our double linked list as a stack by using this pop and push instead of add to head, add to tail.
that's it.
But it's the same, yeah. Because you see, if I call pop, I'm going to call delete from head. So it's just basically the same thing, yes.
What's the benefit then to,
What's the what?
what's the benefit of DLL stack?
This is DLL stack. I mean, which one? This one?
Yeah, this one.
Well, you could use that too, though. Yeah. Is it what was asked?
Yeah, I think
Well, the question was DLL instead of linked list. But yes, we could have used this DLL stack.
I use the DLL stack.
Okay, if you use the DLL stack, you don't have to change anything in the DLL. You don't have to add anything like that. But because the question says, okay, I would like to change that with the DLL, so not the DLL stack, then I don't have the push and pop, so I have to put them. And that's it. I have one mistake, and that is this top L. I'm sorry? No, that's not the message I'm getting here. It says cannot find symbol top L in the DLL. There's no such method called top L, top element. But I have get first and get last. So for me, top element is the first one, right? Is the head. So I'm going just to do the same. Public T top L, and I'm going just to call, return get first. Now which one is it? This one? Now it doesn't have any more problems, and it should be working fine, inshallah. Is that okay? There's different ways how to solve this, but You just need to, when you're using a double linked list as a stack, you need to just take a decision. Is my head going to be the top of the stack, or the tail is going to be the top of the stack? And then you put everything accordingly. You stick to it. Yes. Yes.
The stack is a list. One list.
Can be used. Yeah. The stack, as you can, the implementation of a stack can be a list, double linked list, or as we mentioned yesterday, it can also be an array. If I want to make a stack implementation of inside of an array instead of a list, I could do that. But just in the memory, in the computer, there's no horizontal, and it's just our representation of it that we need to just do kind of representation. For the computer, these are just numbers, and there's one before the other. It's like now if you have this as a stack using a double linked list, there's no top and bottom as in the stack. The stack has a top and a bottom, but there's just right and left here, previous and next and previous. So which one is your top? It's you who to decide. It's you who decides. And then you just, when you say the top is the first one, okay, so this is you're going to be, the head is going to be the top of your stack, which means every time you push the head. Every time you pull, you pop from the head. If you decide no, you know what, the top of the stack should be the last one, because I'm going to always add to the head, to the tail. So now this is the top of your stack. So every time you push, you're going to push to the tail. It's just a representation, but at the end the stack is a concept that when you add something, this is the last one that was in is the first one to get out. Last in, first out. That's think how it works.
So if I add from the tail, it will be up.
If I add from the tail,
It will be add up
the tail is going to be the top. Yes. If I add to the head, the head.
If I add to the head, it will be down.
The head. What do you mean?
If I add to the head, it will be down.
What will be down?
What I add to the stack?
Well, in a linked list, there's no up and down.
No, I mean that.
I mean the tail you're talking about. The tail will be down.
The tail will be up in the stack.
Okay, now let's say this is the stack.
The top.
This is the stack, right? This top element is what to you?
The tail.
The tail. That means I'm adding to the tail, and then I'm so this is the double linked list, and I'm doing something like this. So when you add something, you add it to the tail. When you pop, you delete from the tail. Okay.
Yes.
Now which one is up?
Tail.
The tail is up. Okay. Now if you just do the head, you delete, you add them differently. Okay. Let's cancel. Now if you make the head to be the top, then you're going to be adding to the head every time you add to the head, you add to the head, and then your head is going to be the top.
The head will be the top.
Okay. I prefer this way, because the way you said it was confusing. I didn't get it.
Changeable.
Exactly. Just two directions. Just up to you to decide. All right. Now the last thing is do the same thing with the student. Do we have something instead of well, instead of doing this, I can use the same thing with the student, but I don't want to. Or what I could do, it was from lab 2, I think, when we had something with the student. So I can just take this one and copy it here. Yes. And also take this test student and copy it here. But this time I'm going to, what's the name? Test student stack. So let's just rename that to test student stack, refactor. So now what I'm going to do, just because well, I don't want to use this one, I'm going to use my DLL stack. I have this DLL stack already, so I can use that. And then basically instead of add to head, I'll push. But I don't have now this add to head or tail. I'm going to say just push, push a node and pop. Push a new node. I can print all nodes fine. I can delete, which means pop. Then pop a node. And we don't need to do these. Well, we could use these if we want to.
We use it's open.
It's what?
This set of clicks from the tail or something. We could use top
Top element, just to get the top element to display something. Yeah, we could just display top element. And then, well, we could search for a node if you want to, but well, we can leave that. So anyways, I'm going to, I leave the same numbers. It doesn't matter. You can just make them more, I mean, sequential, so you don't have to think. I'm just keeping the same numbers because I don't want to do a lot of changes. So 1, we keep that, but we call it not add to the head. We just push. The 2, we don't have that. The 3, there's no print all. There's no print all. We remove it. No, but if I would like to print all, what should I do? Pop. If I pop, I'm going to delete every time I display. So I will empty my list if I pop every time I do that. Now this double linked list stack is using a DLL, but there's no method that is display all. But I can use the print all that is from this list. But this is private, I cannot have access to it, so what I can do, public void print all, and there's a print all that is going to be from the list. There's a print all from the list. So I'm using, again, so I can print all. I'm having the print all now that is going to work, because I created in my, let me just this so I can avoid the confusion. In the DLL stack, I just added a new method that is going to call the one that is from the double linked list. So I fixed my problem. I don't need to have 4 and 5. I say 4. Yeah, pop a node. Yes, we do need to have that. So there's no delete from head, but there is pop. And then there is no delete from tail. And we have top element we set for 6. Okay, so the top element, we don't need to enter anything, we just need to return something. So let's just remove this. Well, how to get the top element? It just, we're just going to display, or maybe just the top element is, and then I display top. First of all, yeah, list, then top element. So this is going to display the top element. Okay, what else? Search for a node. I don't need to change anything except that there's no find, so I don't want to put the code for find because it's not what we would like to do. So basically I'm just making this work with this push and pop, so that's not a big deal. Now let's go for some interesting things, which is the exercise number 2, where we would like to have a simple method that is going to check if a string is palindromic or not. It's palindromic if the same letter is exactly the same as the last one, the second one is exactly the same as the one before the last, and so on. Now, in order for us to do that, there's like a simple for loop that we can do with the if. This is something we did in Java 1 some time ago, but we can now we would like to use a stack to do that. Now the idea is the following. What's the idea? No. Let's cancel everything. I want to. All right. The idea is the following: we have a string. Yes. Yes. I hope so. Yeah. So what I wanted to say is that we ask the user to give us a text, and then if the text is palindromic, that means we need to display it. If it's not, we need to ask him, no, it's not palindromic. But how can we check? We'd like to use a stack for that. Now, how to use a stack for checking if it's palindromic or not? This is what this says. Scan through the string and store each character in a stack. So we have the stack. Let's say the user gives us mom. Mom is palindromic because the first one is exactly the same as the last one, and the one in the middle, we don't care about it. So what we need to do is that we need to push one by one. The first one pushed, the second one pushed, the third one pushed. So we push all these here. The result of that is that when I pop, I'm going to pop the last letter. Then this is scanned through the string again, comparing each character with the next character pop off from the string, from the stack. And then if they're not equal, then it's not a palindromic. It's not a palindromic text. So what I'm going to do now, I'm going to go again, now and this time pop. Every time I pop, compare with this. They are equal, okay, continue popping. Pop again, is this equal to the next one? Yes, okay, I keep popping, equal to the next one, yes, until this stack is empty. Once it's empty, and I mean that means that I was able to compare all of them and they're all true, I'm going to display, yes, it's palindromic. If for whatever reason, like it's something, I don't know, mommy, whatever. So if it's like this now, when I pop, I'm going to compare this one with this one. It's not going to be equal. I don't need to keep popping, just okay, stop and display. They're not equal. So as soon as I find that they're not, it's not palindromic, I'm going to display it. If I'm not, I'm going to pop until the stack is empty.
I just found one not equal, I stop.
Yeah, of course, because if one is not equal, it's not palindromic.
What
Yes.
about if it's string?
If it's what?
If the mom is string,
Well, the mom is string.
so how will they take it the opposite? Char by char.
Well, we put a loop to get one char at a time. We're going to do that. This is what we're going to do. So let's first of all, let's just pick something. Let's say I'm going to. Okay, let's just create a new one. New class, and I'd like to have it main. There's no option. No. Okay, finish. Okay, I'm going to call it test palindromic. Okay, public static void main string arg, and remove this star. Now what I'd like to do is to have a method. I'm going to test it here, but I would like to ask the user, let's say, let's just have this scanner, just where I can ask the user equal new scanner system.in. Now please enter a word. Now I'm going to read the word, and to do that I'm going to call it word is equal to kb dot next line, just next. That's, I just need a word, and then once I have this, I would like to call put some kind of if something is palindromic, let's say. So this is palindromic is going to be a method that I will implement. That's going to be a boolean. So if it's palindromic, I'm going to say the text is the word is palindromic. else the word is not palindromic. So now this is palindromic, needs to be implemented, so let's just implement it. So how do I implement that? Well, basically, you know what, I need to give it the word so it can check it. So basically I need to have a parameter to be the word that I'm going to send to this, and this is going to return either true or false, and this is something I'm going to work on later. So how can I, now that it's palindromic, now I'm going to use my stack. DLL stack, this is my stack, equal, it's a stack of what? It's a string? No, I just want one char at a time. But I cannot do this. I need to use the class data type of a char, which is character. Or I can use a string, but I'm going to only store one character. These are both implementations. Which one you would like to use? Character? Let's use character. Okay, new DLL stack, and we just initialize the stack. Now what I'd like to do is to have a for loop. For loop what? From 0 to, basically I just would like to use char at and push that char at into the stack. So I need to know how many there are. So I'm going to call the length, word.length. Word is a string, so it has .length. Now if I'd like to get one char at a time, I'm using a loop from the first one to the last one. How to get one character? Well, we have this char at, and I give it I. Now this char at is going to give me one character. What am I doing with it? I push it to the stack. So in my stack, push, and this. So this is going to give me one char. I'm pushing everything. Push each char, each character to the stack, in the stack. Push 2, push in, push 2, push to the stack, push in the stack. Okay, doesn't matter. Now that I have pushed here,
Just a question for the loop here. I can't use for each because it didn't,
you can use a for each character or char. Then let's just try that. For each in Word, and it's not an object, it says a char, C. I'm just going to call this to be a char. Doesn't work. Why doesn't this work? Because if I go to this string, does the string implement iterable? It complements comparable, which means I can compare which one is smaller than the other one, but there is no iterable, so I cannot use it as using this for each. If I want to, I need to have my string to make it iterable, have the iterator, and this is, I need to implement it basically. So it's not available. So let's stick to what we have, and that's what we have now. A for loop that is going to push every character one at a time. Now I need to do what? I need to ask a question while what? While the stack is not empty, because I need to compare until it's not empty, or if I find that there's not equal, I'm going to break and get out and tell them, okay, this is not. But I need to, in the best case scenario, I need to check every element in the stack. So I need to pop each one of them. So while it's not empty, I'm going to pop a char. This is a char. Let's just how to call it? A char letter. And then I'm going to have this stack dot pop. Now I pop one, and well, it's a character or a char does the same thing, because this is just a primitive data type, but I'm popping one just using character. And then what I need to do, I need to compare if the letter equals what? Now I popped one from the stack. I need to compare it with what? With the first character in the text. So how can I do that? Is this equal to the same thing? I need to have something word char at, well, 0, but I cannot just always put 0. It should be a variable. It should start from 0. Next time it's 1. So let's put I. I still need to have an I that is initialized to 0, and then once I check, and if it's equal, I can increment after that. So it's 0, check it's used at 0, or not to confuse you, I can just put the I++ here. But I could put the plus there, it's not a problem. Which one do you prefer? Plus here or plus here?
Then what we usually do, but also
This one is fine. So it just just know what I need to do is that I'm going to use the I, the value 0, and then I'm going to increment it to 1. So next time I get in, I'm going to use 1, and then increment it to 2. So if I get in, I'm going to use 2, etc. So I made this now to compare this letter, is it equal to that letter? Now this returns a char, just to show you the return type. Okay, it doesn't want to stick, so I can click here. Yes, so it returns a char, and I'm comparing with a char or character. I could use also char, it's the same thing. So I'm comparing two chars, two characters. If they're equal, what should I do? Actually, if they're not equal, then I should do something. If they're equal, I'm not doing anything. So if they're not equal, I need to remember that I braked because it's not palindromic. So I need to, okay, return false, for example. That's one way to do that. So if I find that they're not equal, okay, stop and get out. And we know they're not palindromic. And if we get to the end of the loop without getting out, that means if we were able not to get inside here once, that means all the letters were equal. I'm going to return true. However, a better way is, not a better way, it's a more organized way just to say, I'm going to put a boolean. This is the returned value. I always do that generally. This returned value, I need to initialize it somewhere. So I'm going to put this to be like this, and then I break. And then, you know what, I'm going to make it to be true, so if I don't need to do any extra things. So I initialize it to be true. So if I'm not getting it inside, I'm going to return this returned value, which is going to be true. If I get inside, I make it false and return that. The only advantage of this is I have only one return, as opposed to the other ones. But honestly, it's maybe I just noticed that it adds more complication for nothing. Not a big deal. So anyways, that's now our is palindromic. Let's test it. So I just run the file. Please enter a word. Okay, same as here. Oh, the word is not palindromic. There's a problem. Because the capital and lowercase are not the same. So that's a problem. So I can use this ignore case, but I'm not comparing the string, I'm comparing chars.
you can make them all capital.
That's what I could do. So when I do something like this, for example, when I call the is palindromic, I just put them all capital or all lowercase. So this is the word that I received from the user, but I'm not interested in sending the word, but to all lowercase or uppercase, whatever you want. It will do the same thing. So I'll put them all, for example, uppercase, and when I send them, they're going to be compared as the mom or madam, all capital letters. And then if I run this now, and okay, meant shift F6, and then I type madam. Now internally it's going to be sent to the, it's palindromic to be madam all capital letters. So when I check it, it tells me the word is palindromic. And that's how you solve this.